Hey everyone, it's Jesse from Project FDL. I wanted to do a quick video about flywheel balance and mounting a flywheel on a motor, kind of just to help you guys get your flywheels nice and balanced and get the most performance out of your blaster as possible. It's not absolutely critical that your flywheels are perfectly balanced, but in my opinion, the most efficient running machine is the most quiet running machine. And I do believe that it will contribute to the longevity of your motors if they are nice and balanced and everything. A little bit of background. So there are two major different types of motors, of brushless motors in particular. Our Crux motors that we just had made, the top has 4 kind of threaded holes in it. And you can see on this flywheel here, there's 4 screws that screw in and hold the flywheel on there. Traditionally on a drone or an FPV of some sort, there would be a prop adapter that screwed into place there, and it would have a prop shaft like is on this one. So this is actually a more traditional brushless quad motor where it has a propeller shaft in the middle, and then you have a nut that kind of screws down on top and holds the propeller in place. There are a lot of FDL3s in existence that have this style motor of them. These started becoming a little hard to come by. The original FDL2s, even the FDL1, had this style. When it was hard to get those, I moved over to these. Having the opportunity to have custom motors made, I went back to this style because I feel like this holds the flywheel onto the motor a little better and a little flatter. So when you have a flywheel, and just again for reference, on these old ones, you can see on this flywheel there's these 2 kind of tabs in there, and then there's these slits on the side of the motor. So those tabs are meant to lock down into the openings on the motor. And that's what held it in place. Like even if the nut came slightly loose, it wouldn't slip around, and it would hold it down. On these, you don't have that, which is actually a really nice thing when it comes to designing the flywheels. Instead, you just have the 4 screws on there. Because the Crux wheels are the ones that we are using now, and again, this is sort of my preferred format, I'm going to go over how to do flywheel balancing and mounting with those in particular. There is a nice thing about this style that I sort of forgot to mention, and that is you can actually get a balancer where there's like a shaft that goes through the middle of this wheel, and you set it on there and it kind of spins and it drops the heavy side to the bottom. And that's useful, and that works really well for propellers. My preferred method is what's called dynamic balancing. So rather than officially finding like the weighted side of the wheel and cutting off of that or whatever, we're actually going to run it, and we're going to kind of do it by feel and do it by ear. So before I get too far into this, I'm going to show you this and sort of go through what I do here. I have this little jig here, and it kind of has these arms that hold on to the motor. You could potentially mount your motor to your outer barrel, your actual mount on your blaster. And then I have the tail. I have a semi-tail here that I have kind of kicking around the shop. If I turn this on, I can actually run it. So I have actually already gone ahead and I've balanced this wheel. It's pretty nice because I wanted to show you and kind of give you an idea of what we're looking for here. Before you do this, before you run any of your stuff, I highly suggest that you are wearing eye protection, and it probably wouldn't be a bad idea to wear like a safety glove or something. I don't know. Your other option is to maybe put this on a board and clamp it in place such that your hands aren't near it or something. I've done this a lot. I'm pretty comfortable with it. But again, protection is a big deal. So like I said, I have this one balanced already. If I run it, it's pretty smooth. You don't hear a lot of vibration. So over here, if you look at my tail, I have a bunch of little pieces of E-tape. So like this is electrical tape. I like to use electrical tape because it's fairly easy to put on and take off. It's also a little heavy too. It's not like masking tape where you'd have to put kind of a bunch on there in order to weigh the wheel in one direction or the other. So again, this runs pretty smooth. If I was to take a fairly decent sized piece of electrical tape and stick it here and run this, suddenly you can hear that that's much more vibrating. So what we've done is we've actually applied weight to one side of the wheel such that that side of the wheel is heavy now. And then when you run it, it vibrates a fair amount. So that is sort of like the reverse direction of what we're going to try to do here. So yeah, I showed you that. I have this other motor here. I have a flywheel here. We're going to work on balancing that. So I'm going to shut this down. Right now I only have the signal wire for that particular ESC hooked up. That's this one. So I'm going to undo this. I'm going to plug the other one in. Be really careful when you are handling this board. If it is outside of the blaster, you could theoretically kind of put it inside your ESC housing so it's all together. But if this is on, keep in mind you are hooked up to a LiPo or a power supply or something, so if you hit this like with a screwdriver or something, you're going to get a wicked zap and it's going to be not cool. You may break stuff, so just be really careful. So I have that other one hooked up. Let's take this off here. That one instead. Right, so when we're running just that, it's nice and smooth. So let's talk about actually mounting the wheel. Again, on these old ones, when you mounted it, you had to get these tabs kind of down inside of the openings on the wheel, and sometimes it didn't go on there super nice. This is a little different. So this, you just put on there. And the key here is just to line up the screw holes. Put the holes in the motor, push it in place. Now, here's a concept that's pretty important too. When you're balancing your flywheel, you are not only balancing the flywheel itself, you are actually balancing the flywheel and the bell of the motor and the screws and the Loctite. All of that makes up a unit that has a certain amount of mass, and some of that mass can get out of balance in one way or another. You'll notice that this one that was balanced, I haven't taken off of the motor. I will leave it on the motor now that it's balanced because it's balanced as a unit with the motor. That being said, when you get this actually balanced, avoid taking your flywheel on and off. Once it's balanced, leave it on there. If you do take it off, take note of what orientation it is on the motor. Obviously, because there's 4 screws, you can put this on in 4 different directions. These Crux motors are very nicely balanced. That was a big deal to me when we have them made. Some cheaper motors are less balanced. There are very high-end motors that are like whisper quiet, perfect balanced. These are very nice. I'm very happy with them. But even a minute, tiny little bit of imbalance in the bell can actually contribute to the balance of the whole unit, including the flywheel. So if you put the heavy side of the flywheel such that it aligns with the heavy side of the motor, it's going to be fairly out of balance. If you end up, and this is sort of a random, you have a 1 in 4 shot of this, if you line this up so that the heavy side of the flywheel is opposite the heavy side of the bell, you may actually just put this wheel on and it's balanced and it's good to go. That's kind of nice, actually. And if you don't want to go through the entire process of balancing, one thing you can do is put these on and rotate the orientation of the wheel on the motor until it finds the best spot. I'm going to kind of wing it here because I know that these wheels have come off the printer fairly balanced. I've kind of tweaked my settings and stuff such that these wheels are as balanced as possible when I pull them off the printer and go to put them on. So I'm just going to kind of put them on here. Okay, so again, I'm going to put this on so that those holes are lined up. These screws that go in here are 2.5 millimeter by 5 millimeter long flathead screws. On some of the older, like the original FDL3 motors and the FDL2 motors, these are actually M2 screws. I had these holes made a little bit bigger on here because I wanted a little bit hardier of a screw. That makes these a little bit of an awkward size to find, but in the bill of material, you can find them on McMaster and various places. So you do want to use Loctite. So I have a tube of Loctite here. This is Loctite 242 blue. It is removable. Don't use the red stuff. The red stuff is permanent Loctite. If you use that on this, you will never get your flywheel off again. So I usually put like a few drops on like a little baggie, and then screw this into place. You want to do this in a crisscross fashion. So that screw that I just put in, I did not tighten down. I only got it like semi-snug in that spot. And the next one that I put in is going to be opposite that. And then the next one there. Next one here. Okay, and I forgot to mention this is a 1.5 millimeter hex head too. I really like these kind of driver style ones. They're very easy to use. Okay, so we have all of these, and my goal here was to equally snug each of these up. Once I get them equally tightened, do that one, come down to this one, move over to this one, move over to that one. Okay, and that pass, I only tightened it about a quarter of a turn. Now do that same thing all over again, and I'm trying to maintain, and this is a feel thing, trying to maintain equal tightness of all four of these screws as I do it, and I keep going in this crisscross fashion. Dum, 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 dum. Okay, so those are good and tight. So let's see. This one's pretty good, just like that. I could theoretically just throw that on a blaster, but I want to get this even closer. Okay, so what we want to accomplish here, so we want to find the heavy side of the flywheel. If you look here at these different pieces of electrical tape that I have cut, I have a bunch of different sizes. I have these big ones that's sort of like a medium one, these two little ones. I'm going to grab this medium one and try to not get the sticky stuff on your fingers. The oils of your fingers will really rub off the adhesive on the tape. I'm going to kind of randomly stick this down from one side of the wheel like that. Okay, when I did that, it actually made it a little bit worse, which means I didn't find the heavy side. So I'm going to take it off, rotate the wheel 90 degrees, and put it there. Run it. Not bad. Could be better. Next one. That is really nice right there. I am going to do one more rotation just to check. Yep, not as good. Back here, check one more time. It is definitely the quadrant that makes the wheel spin the absolute smoothest. You can get very picky here, and you can try putting the tape like on this section. I would say, work within the quadrants first. If you do this a couple times and you get used to it, you can move to these kind of extra diagonal spots. But for now, that's the side. So we've put the tape on, which means we've actually put the tape on the lighter side, and it has counterbalanced the weight on this side of the wheel. So we need to remove material from that side of the wheel. I'm going to take a Sharpie, I'm going to put a little dot on there, and if you get a built blaster bias and you look inside at your flywheels, they'll probably have that little dot because I've already balanced them. So then we take the piece of tape off. Okay, and then I have this reaming tool. This is a really great tool to have if you are into 3D printing. It's really great for removing little bits of flash and brim and stuff off of prints. We use these pretty heavily, and it works really great here. You could potentially use an X-Acto knife, but this is going to be the safest way to go. I should mention too that these are ABS wheels. ABS is actually very easy to machine, so when I get in here and I start taking material off, it's going to be fairly easy. If you've printed PLA wheels, it's a little bit more difficult. Okay, so we found that this is the heavy side of the wheels. So I'm going to turn this over. I'm going to take this, and I designed a sharp rim into the inside of the wheel here, and I did this very deliberately because it gives you a place that you can actually nibble off some material. So I'm going to take the reaming tool and I'm going to cut a slice off of that rim, and I go from kind of 45 to 45. I'm actually going to do one more light pass. You want to take a little tiny bit off, and if you look, this is what we're taking off of this, just this little sliver of material that weighs virtually nothing, but it makes so much of a difference. To run that, I'd say it's like a little bit better. When you do this a couple times, you kind of get a feel for how much weight you're taking off in each pass. You just keep kind of going. Be really careful when you're doing this too. You've got these pretty blue motors here. If you reach in too far with your cutting tool, you could scrape the motor, and you got a permanent cut in your nice blue finish. It's pretty good. It's good every once in a while. So one thing that can happen if you are like really heavy-handed taking material off of here, you can actually go the opposite direction, such that you've taken too much material off and now you've made the opposite side heavy. So I do every once in a while, I take one of my little pieces and I stick it on there. And I just kind of double check that I'm still taking off of the heavy side. Which I am, like even with a little tiny piece on there, it's a little bit better. I think that's pretty good. Okay, so now to finish, what I usually do, I want to hear like what this is going to sound like. It's all together. Shut that off. Both on there. That's pretty good. You can get really, really picky with this, and man, if you get this down really, really nicely, you can get a virtually whisper quiet blaster. It takes a really long time to do that, and you know, sometimes it just happens. This is gonna be, that's gonna be pretty quiet inside the blaster. I'm really happy with that. But again, yeah, that is how I personally balance flywheels that go into blasters that we build in the shop. When brushless motors are made in the factory, this is how they do it as well. Granted, they usually have a really nice machine that you put the bellow of the motor on, and it tells you which side is out of weight, and they put like a little piece of epoxy on there or whatever. You could potentially build the back half, like your auto half of your blaster, and do the same thing, just, you know, when you rev it, your pusher's gonna push out as you're doing this or whatever. But I hope that helps you guys, and I hope that, you know, that helps you have a really smooth running, awesome sounding FDL3. And thank you for watching, and make on. Good luck.